Number 10 has a roller coaster, and it has 4 different points labeled that gives you some heights, all relative to the same line. And they say there's no friction, and then calculate the speed at points 2, 3, and 4 if it starts at point 1. So this is straight up conservation of energy, and the only energy types present will be potential energy due to gravity, which is m times g times the height above some reference line, and potential or kinetic energy is 1/2 mv squared. And the other thing is conservation of energy. If the car loses potential energy, then the place where that potential energy goes is straight to kinetic energy. So you need those 3 things, and you will be able to calculate how fast it's going. So from point 1 to point 2, identify the total energy at point 1, and it is released from rest at point 1, so it has no kinetic energy. And so all of its energy is potential at point 1. We don't know the mass, but that's fine because you'll see when we do the calculations that the mass will cancel out. So mg times 35 is the height. And since all the height measurements are relative to the same line, we can just use the numbers they give us. If they weren't all measured to the same line, we would need height values all measured to the same reference position. Okay, so at point 2, it will have kinetic energy, 1/2 mv squared, but point 2 is actually on the reference line that we're using. So there is no height for point 2, or the height is 0. So the potential energy at point 2 is 0. And so the energy at point 1 has to equal the total energy at point 2. That's conservation of energy. So mg times 35 has to equal 1/2 times mv squared. Here's where the m's cancel, and so v equals the square root of 70 times g. I'm just going to stop there. If you need a number, you can plug in 10 for g. So that's the velocity at point 2. All right. For point 3, you could go from 2 to 3, now that we know how fast it's moving at point 2, or you could go from 1 to 3, and you would get the same speed either way. There's not really an easier method. Usually, if you have to pick a point, you want to pick a point that's going to make it easy to calculate things. So the points where it's 0 potential energy or 0 kinetic energy are useful. But point 1 has 0 kinetic energy, point 2 has 0 potential energy. So either point would be easy to go straight from that to point 3. So I don't see an advantage in either way. But most people working this problem would probably do it 1 to 2, and then 2 to 3, and then 3 to 4. So just to show you that you don't have to do that, I'll go from point 1 to 3. And not 2 to 3. Not that there's anything wrong with 2 to 3, though. So at point 1, we already know its energy is 35 times mg from looking at it over here. And that's going to equal the energy at point 3, which there will be some kinetic energy. I'll call the velocity at point 3 v3. So it will have some kinetic energy, but it will also have some potential energy. And that potential energy is m times g times the height, which is 28. And so now you have to solve for v. If you move this term over to that side by subtracting, these are like terms. So 35 minus 28 is 7 mg equals 1/2 mv3 squared. There's an m in both terms, so that cancels out. Multiply both sides by 2, so you get 14 equals v3 squared. So v3, oh, there's a g there. v3 is the square root of 14g, which it should be slower than at point 2, which it is, so that makes sense. All right, for point 4, to answer this one, you could go from 1 to 4, look at the energy at point 1, equate that to the energy at point 4, or you could go 2 to 4, or you could go 3 to 4. Since we know all the information about points 1, 2, and 3, there's no real advantage on any of them. But just to show you again that you don't have to work it sequentially, 1 to 2, 2 to 3, 3 to 4, I'll go from 1 to 4. So at point 1, I know the energy is 35 times mg, because it's just potential energy. And I know that's going to equal the total energy at point 4, which it will have some kinetic energy at point 4, but it will also have potential energy, mg times 15, because the height above the reference line for point 4 is 15. So now it looks like the last one where we have to subtract this term from both sides, and this time you get 20 mg after you do that subtraction. And then if you solve for V4, you get the m's cancel. You'll get V4 equals the square root of 40 times g. The 40 comes from multiplying both sides by 2 to get rid of the half. And just checking it, it looks like 0.4 should be faster than 3, which it is, but it should probably be slower than 2, which it is.